This lesson is for my Advanced Math 7 classes at J.B. Martin and Hurst. J.B., part of what is going to be on this lesson is what you saw the other day. In my notes to you on my webpage, I'll tell you at what point you can skip to. Hurst class, you should watch this from the beginning. Okay. When we took our notes last class, this was one set of notes that I believe that we left out, the power of the power rule. When you have x to the m to the n, it's going to be x to the m times n. So when you have the power of a power, you actually multiply those powers together. And here's a brief explanation why. Okay, so here's an example, d to the third to the fourth. Well, to multiply, or to bring something to the fourth power means to multiply 4 of them. So this is what d to the third to the fourth means. And we learned in our last lesson that when you're multiplying powers with the same base, you can simply add the exponents. Well, 3 plus 3 plus 3 plus 3 equals 12. So this is d to the 12th. Notice that 12 equals 3 times 4. This is why this works. Second example, 6 to the 4th to the 5th is simply 6 to the 20th. You don't have to figure out what 6 to the 4th is. Just like the d stayed the same, the 6 stays the same. This next example, okay, this is 5 times f to the 6th to the 5th. So we have the power of a product. So I'm going to do 5 to the 5th times f to the 6th to the 5th, which is going to be equal 3,125 f to the 30th. Yes, I did use a calculator for that. For my last problem, let's see, I have multiplication, I have exponents, I got to follow a lot of operations. I believe I need to work out this exponent problem and this one, and then multiply it all together. So the first part is going to be 2 to the third times w squared to the third, which equals 8w to the 6th. The second part is going to be, let's see, 3 squared is 9, and then w to the 9 squared when I have a power of a power. That's when I multiply. That's w to the 18th. Now what I have here is 8 times w to the 6th times 9 times w to the 18th. This equals 72 w to the 24th. That is my final answer. The new part of today's lesson is going to be the rules quotient of powers, power of quotients, and negative exponents. In a couple of lessons, we've alluded to the fact that when you have division, or when you have a quotient and you have the same bases, that you can actually just subtract the exponents. Okay, so we have the quotient of powers rule. Why don't you go ahead and press pause and copy this into your notes. Okay, and we've said before why this works. We will not go into that again. So here's just a few examples. R to the 8th divided by R to the 3rd equals R to the 5th. I simply subtract my exponents. 9 to the 11th divided by 9 to the 9th is 9 to the 2nd. 11 minus 9 is 2, and 9 squared is 81. You don't cancel out these 9s because really only 9 of these 9s cancel out with 9 of these 9s. You're still left with a couple of 9s. Now this last problem, notice the 16 and 8 are not powers. The 16 and 8 are just regular numbers. 16 divided by 8 is 2. And then x to the 5th divided by x to the 1 equals x to the 4th. And y to the 7th divided by y to the 2nd is y to the 5th. This is my answer. Go ahead and try to work number 1. Press pause, and then come back when you're ready. Okay. Here's the answer. Let's just look at the d part first. D to the 12th divided by d to the 4th equals d to the 8th, or 4 of these d's cancel out with 4 of these d's. We're left with 8 d's here. And then 11 over 44, divide each one by 11, you get 1 over 4, and then the times 1 is not necessary. Okay, go ahead and press pause as you try number 2. And here's my solution. First of all, the 8 over 12 is just like a regular fraction. I just reduced it by dividing each by 4. And then I can do h to the 9th divided by h to the 1. 9 minus 1 is 8 is h to the 8th. And then c to the 6th divided by c to the 4th. Subtract my exponents. I get c squared. This is my answer. Or you can also just think of it as one of these h's cancel out with one of these, you're left with 8. 4 of these c's cancel out with 4 of these c's, you're left with a couple of c's up here. Your final answer. Okay, I'm going to look at this problem two ways. The first way is I'm just going to use the rule that we just used. Okay, x to the third divided by x to the fifth will be x to the 3 minus 5 is negative 2. This is our first time seeing a negative exponent. Let's look at this a different. The second way of looking at it is like this over here. This is x to the third, this is x to the fifth. 3 of these x's will cancel out with 3 of these x's. We still have our understood 1 right here. So what we're left with is 1 over x times x, also known as x squared. So since both of these are equal to this, these two must be equal. X to the negative 2 equals 1 over x. Just based on that example, we can now add this to our notes. It's on your note page, negative exponents. Anything to a negative exponent is simply 1 over it to the positive exponent. It just works. So press pause and write that down, and then come back. So 5 to the negative 2 means 1 over 5 squared, which is 1 over 25. You're done. Now remember from past lessons, 1 over something is the same as its reciprocal. 1 over 2/3 means, okay, 1 divided by 2/3, or times 3/2. We get 3/2. So basically, 1 over something means reciprocal, because 3/2 is the reciprocal of this. So when you have a negative exponent and your base is a fraction, you can do it this long way, or you can just say, hey, I'm going to do the reciprocal thing, get 3/2 to the positive 2, and 3/2 times 3/2 is 9/4. I'm going to teach this a little better and actually realize that that was a 3. So I can, again, take the reciprocal, because that's what 1 over means, and make it a positive 3. Well, 3 cubed is 27, and 2 cubed is 8. So it's 27/8 or 3 3/8. Either way is good. The last example is a little bit weird. This is the easiest. Well, first look at it technically. There's not much to work out. You got negative 15. It's just negative 15, x to the 6th. Now this means times 1 over y to the 7th. So if you multiply this times 1 over y to the 7th, you will get this. A very simple way of looking at it, and this is my way, is anything with a positive exponent, like this guy here and this guy here, is happy where it is. If it's up top, it stays where it is. If it's on bottom, it stays where it is. But if it has a negative exponent, you have to do the reciprocal effect. So if it has a negative exponent, if it's on top, you move to the bottom and make the exponent positive. If it's on bottom, it has a negative exponent, you move it up top. So right here, this is the only negative exponent, so it has to move from top to bottom. There we go. And one more rule that I actually used in the last problem was the fact that when you have the power of a quotient, you can actually raise the numerator and the denominator to that power. And here's a nice little example of why. If you want to, you can press pause and look at it, and that's a pretty good explanation. So here are 3 practice problems. Press pause, try number 1, and then come back. So answer number 1 is negative 10 over x squared. Here's how I got it. Okay, this is all multiplication, so it's 5 times x to the 5th times negative 2 times x to the 7th. So 5 times negative 2 is negative 10. Then x to the 5th times x to the negative 7 is x to the negative 2. You cannot have a negative exponent in your final answer. So pretty much this means negative 10 times 1 over positive x squared, which will give you this. Or you can just say this guy can't stay where it is. Right now it's on top because that's all we have is top. Move it to the bottom. Now go ahead and try number 2. Press pause, come back when you're ready. Okay, this is all multiplication, so I can do it in any order, any grouping, so I'm going to do it right now. My regular numbers, there's no exponents involved. Negative 15 times negative 3 is 45. C to the negative 6 times c to the 1 is c to the negative 5. d to the fourth times d to the negative 1, add those exponents, we get d to the 3. I cannot leave a negative exponent in my answer, so this puppy needs to come down here, and then I'm done. Now go ahead and try number 3. Press pause, come back when you're ready. So here's the answer for number 3. Okay, I like doing it this way. When I see a negative exponent, I think reciprocal. My base is a fraction, so I just take the reciprocal of that fraction. Make my exponent positive now. So this would be, again, using the power of a quotient rule, I can square my 5 and square my 3 and get 25 ninths, which equals this. Or you can say, well, a negative exponent means 1 over, so it's 1 over 3/5 squared. So that's 1 over 9/25. So that's 1 divided by 9/25, which means multiply by its reciprocal, so we get 25 ninths, which also equals this. That was the slightly longer way of doing it. Okay, here's one last problem. It's multiple choice. Press pause, come back, and we'll talk about it. Okay, it looks like the answer is A, because when you work this out, here we have a power of a power. You multiply your exponents. Okay, I'm going to wait on this, because I have to do exponents first. I have a power of a power, so I'll multiply my exponents. Okay, now I have my multiplication sign. Now I have the product of power, so I'll simply add my exponents, and here we go. So both my second period class and sixth period class should go to my webpage and download the exponent worksheet 2. That is your assignment. I will see you tomorrow. Live long and prosper.